So in this video, we're going to talk about the basic knowledge about circles. Okay, let's just start to the first slide. Okay, so these are the basic things that you need to know about circles. The definition for the first one is a circle. What is a circle? A circle is a set of points which are equidistant from a fixed point, which is called the center. So if we have a center, if we had like one point over here, and then all of these that you can see here is actually just like a set of points. So a lot of points that makes a like a curve, right? So every time you drag a straight line from this center point to that not any point on that here and here, right, you'll get the same exact distance. That's why we call it equidistant. Okay, that's the first one. The second one is the circumference is the distance around the entire circle boundary. So circumference is basically just perimeter. If you understand about the perimeter of two-dimensional shapes, then this is actually the same thing. It's just a different name because it's a curve, right? So if you go from one point and then you go circles and you go around that and then you go back to that circle, to that point, that is what we call the circumference. Okay, the next one is an arc of a circle is any continuous part of the circle. So the arc is actually if you put one point on the circle and another point over here, for example, if you go from here to here, this is what we call an arc. So basically, it's just a part of the circumference. Like it can be like half, maybe 3/5, or yeah, it's just like the part of that circumference itself. Okay, the next one is a chord. So a chord of a circle is a line segment joining any two points of a circle. So for example, you have a point over here and you have another point over here, and then you drag a line from the first point to the second point, right? So it is inside the circle like this. Then this is what we call a chord. So you can put any point you want, for example here, and then you drag a straight line. That is also what we call a chord. Okay, the next one is a semicircle is a half a circle. So if you drag a line from here for center, right, like you drag a straight line to the left and to the right, for example, like this, right? You're splitting the circle into two equal parts, right? So that is what we call a semicircle. Okay, next one is a diameter of a circle is any chord passing through the center. So if you have a chord, for example, like this one, a chord, right? This line is a chord. So you have one point here and one point here, and then you drag a straight line from those 2 points, and you get a chord. So specifically, if the chord is passing through the center point, we call it diameter. So if you have a point over here and point over here, and then you drag a line from those 2 points, and then that line passes through exactly the center point, it passes through that point, this is what we call a diameter. So as you can see that if we have a diameter, this line is actually that split this circle into two equal parts, right? So if you have this line over here, which is a chord, in which the chord is passing through the center point, that will split this circle into two equal parts. So this is a semicircle. This is also a semicircle. Okay. Next one is a radius. A radius of a circle is any line segment joining its center to any point of the circle. So if you drag a line from the center point to any point on the circumference on the circle, for example, like this one here, over here, we have a point, and then drag a straight line. This is what we call a radius, right? So if you can see that if I drag a line from here to here, this is also a radius. If I have a point, for example, over here also, if you drag a line from the center point to that point, that is also going to be the radius of the circle. Okay, the last one is a tangent to a circle is any line which touches the circle in exactly one point. So if you have a point on the circle, the circumference of the circle, for example, like this, and you have a straight line, right, which passes through only that point, right? So it doesn't passes through on any other point in the circle, right? Like for example, like this one, no, that is what we call a tangent. So it will only passes through this one single point on the circle. Okay, next we're going to investigate a couple of theory in a circle. So the first one is if we have a circle like this, and then if we make a what do you call it, the diameter, right? So for example, I'm going to make a line I'm gonna make it array actually. So for example, from here, remember that if you are talking about diameter, it means that you go from a point on the circle and then it passes through exactly in the middle like this, right? So if you have the diameter is just basically from C to D. This is diameter. Now, what if we which means that we're splitting this circle into two equal parts, right? So this is a semicircle, right? So the C, A, D, and then go back here. This is a semicircle. Now, what we're going to investigate is if we drag another line, for example, let's say I have another point over here, anywhere on the circle, and then I'm going to make another line here, line segment from this point here to here, from the edges of the diameter here and here, right? So what we're going to investigate is what is the angle over here. Okay, so to measure that, we can go to measure and then we go to angle here, right? So we can go here, here, and here. Okay, as you can see that the angle is 90 degree. So what happened if I move that, sorry, what happened if I move that point, that E point, to somewhere else? I mean, but it's still on the circumference. Can you see that if I move that anywhere I go, it will always be 90 degree. It's also going to be going down. So this 270 is actually like 90. So if I go here, is just 90 degree, right? So can you see that this is always going to be 90 degrees? So if you are going to, for example, finding the angle over here and over here, notice that we have the theory of the sum of angles in a triangle is 180 degree. So we're going to discuss that later on a couple of examples. So this is the first theory, the investigation or theory that we can find, that if you have a semicircle and if you have a point anywhere on the circumference, right, and then you drag a line, or you have a line from the edges of the diameter, and then go to that point over here, for example, then this angle is always going to be 90 degree. Okay, so from our investigation, we can actually try to use that theory to solve this question. Okay, so example 1, find x given brief a reason. So we have here, this is a semicircle, so given this is a semicircle, and then this angle here, angle A, this is x plus 10, this angle is 3x, and we don't know this angle, right? So based on our investigation, this is a semicircle, right? So as you can see that the previous investigation that we had, this is always going to be 90 degree, right? Like this, 90 degree. Right, so which means that if we have this 90 degree, we can actually use the concept or the theory of the sum of angles in a triangle is 180 degrees. So again, the sum of angles in a triangle is always going to be 180 degree. Now, we already learned about this in grade 7, right? So let's take that triangle and move it somewhere else. I'm gonna make that triangle here. Okay, I'm gonna try to make that as accurate as possible. Okay, so I'm gonna move that here, for example. So we have point A over here, point C, and point B, and this is 90 degree, right? Okay, now this is x plus 10, and this is 3x. Now, because we know that the sum of angles in triangle is 180 degree, so if we add this angle plus this angle plus this angle, it will always be equal to 180 degree. And from that, we can construct an equation. So I can say that, oh, if x plus 10, this guy, is added with this guy, 3x, and then we add it again with this guy, 90 degree, right? It will always be equals to 180, right? So you can solve this equation, right? We already learned this in grade 7. Okay, so I'm gonna combine this x and 3x, which is going to be 4x, and then I'm gonna combine this and this one, which becomes 100, right? Equals to 180, and then I'm gonna subtract both sides by 100, right? And that'll be 4x equals to 180. Sorry, it's 80, just 80. And then I'm going to divide both sides by 4. So x equals to 80 divided by 4. And x is equals to 20. And there you go. You have the value of x. Okay, the next thing that we're going to investigate is about the chord of a circle. Remember, that chord is just line joining 2 points from the circumference of a circle. So, for example, if I have a point over here and then another point, for example, over here, you can put any point you want as long as it's on the circumference of the circle, right? And then you just drag a line or make a line segment from those 2 points. So, for again, like from C to D, for example, right? So you can move that point anywhere you want. For example, like I'm gonna move it here, right? Right, anywhere you want. So this line here, this straight line is a chord. Okay, I'm gonna just like make that the color different. For example, red, so that you can see what happened. Okay, the thing that we're going to investigate is if we make a perpendicular line from point A to line CD, what will happen? Okay, so I'm gonna go to perpendicular here, construct perpendicular line. I'm gonna go perpendicular, and then I'm gonna make a perpendicular line from point A to this line over here. Right, just click it, and then I'll get perpendicular line. So to make sure that it's 90 degree, you can actually perpendicular is a 90-degree angle, so you can actually, for example, put a point over here just to make sure that it's 90 degree. For example, like here, point E, and then you can measure the angle again like before. You go to angle like this, and then you go from, for example, D, and then E, and then okay, not D, maybe from A. I'm gonna go from A, E, and right. See, you can see that this is 90 degree. That's why we call it perpendicular, right? 90 degree. So this is just confirmation that it is 90 degree. Okay, but we don't really need that. Okay, so and then what happened here? Let's measure the length of line DE and also EC. Okay, so we can actually go again measure a distance of length. So go to ED to E, and then C. Okay, maybe I'm going to this one is 1 decimal place. I'm gonna set this into like a couple of this is decimal place. I'm gonna go to, for example, 10 decimal place. So this is this. So you can see what happened here. Okay, so this is 0.71171. You don't really need to calculate this. I just want to show you what is the number. Okay, so you don't have to memorize anything in here. So again, I'm going to also going to measure from E to C. Okay, can you see what happened here is that these two numbers are the same. So what does that mean? It means that if we make a perpendicular line from the center point and then perpendicular to the chord, right? That point here that made from this perpendicular will split this line into two equal parts. So it will always be the same. So from here to here, from D to E and then E to C is going to be always going to be equals. So to prove that, if I just move that through to another point, for example, I'm going to move that. This is still a chord, right? So CD. Can you see that the number is still the same? 68612306554. So this is the same thing, right? So if I move it anywhere, it will always be the same. It means that, again, the theory is that if I have a chord and then I make a perpendicular line from the center point to that chord, that is going to be bisecting this line into two equal parts. So it's going to be like this from here to here. It's going to be the same length with here to here. So DE is going to be equals to EC. Okay, so we're going to use this concept and then try to solve some questions. Okay, so we're going to try to solve this question using the concept that we just got from the investigation. A circle has a radius of 4 centimeter and a chord of length 6 centimeter. Find the shortest distance from the circle center to the chord. So basically, you are going to go from the center point. Let's name that, for example, point P. And then it goes, it's said that the shortest distance. So if we're talking about shortest distance, is going to be the perpendicular line. So from P to this chord here, this chord is say 6 centimeter, the length of the chord. And then you're going to drag a perpendicular line from here to here. So this is going to be the shortest distance from the center point to the chord. Okay, so for example, if you go from here to here, that's not going to be the shortest distance, right? This line is going to be longer than this line. Okay, the same thing if you have like a, what do you call it, a rectangle triangle, right? So this line is going to be always the longest side, right? So that's why this is going to be shorter than this one, right? So yeah, so there you go. So again, we know that the radius is 4, right? So again, if you see that this B and point A and point B is the 2 points that constructing the chord, right? The chord of the 6 centimeter. Now we can just like, okay, so because we already got the image here, the image, so you can just like, okay, so let's see what happened here. So we have this is the line that we're talking about, like to find the short distance. This is what we're talking about. So this is x. So let's draw this and put it somewhere else. So I'm gonna take one of them. It can be p. You can choose to the PMB or the PMA. It's the same thing, right? Because we know that this will split this into 2 equal parts, right, from our investigation. So it means that if we are splitting this into 2 parts, if this PM splitting AB into 2 parts, so it means that from B to M is going to be 3 centimeter, and from M to A is going to be also 3 centimeter. Okay, from this information, we can just take one of the right angle triangle. I'm gonna use the PMA, the same thing, right? So again, guys, yeah, one more thing, I forgot. So it said that the radius is 4. So if you go from P to any point on the circumference, it's going to be always 4 centimeters, right? So for P to A is 4 centimeters, to P to B is always 4. For example, another point in here, for say C, I'm gonna go there, is also going to be 4, right? So that is one of the things that you have to know. Okay, now I'm gonna go and try to take one of this triangle. I'm gonna take this one here. So why I'm taking one, because we're going to use this. We're going to use the Pythagoras formula. So I'm gonna make this a little bit bigger size. So so you can, I'm gonna zoom this a little bit, guys, so that you can see it. Not zooming, actually, like make it a little bit bigger, so you can see what really happened. Okay, now this is point P, and this is point M, and this is point A. As we know that this is a 90-degree angle, so which means that this is a right angle triangle. In a right angle triangle, we know that we can use the Pythagoras formula, right? Pythagoras formula, which is c squared equals to a squared plus b squared. Okay, now in here, what really needs to be paid attention is that this formula, this c is going to be always the hypotenuse. It's going to be the longest side, right? So where is it? It is always in front of the 90 degree. So this is 90 degree. It's opposite to that. Opposite means that in front of that. So this line is going to be the C. So for A and B, for this case, right, it doesn't matter. You can have this one is the A, this one is the B, or the other way around. Oh, okay, this one is A, this one is B. It doesn't really matter, right? You will still get the same exact result. Okay, so the one that is really matter is the C. Okay, so let's say this is C, right? So let's say I'm gonna name this with A and B. Now from the information from this one here, we know that from P to A is 4 centimeter, right? So I'm gonna use other color here so you can see what happened. So this is 4 centimeter, right? So which means that the value of C is 4 centimeter, right? And then we also know that from M to A is 3 centimeter, so this is 3 centimeter. And what we're looking for is this PM. It's denoted by the letter X, right? The variable X. So this is X centimeter, right? So since all of these measurements are the same, so I'm gonna use the measurement on the final result. Okay, so again, from this formula you can just like plug in everything, right? So you know that the C is 4, so just write down 4 over here. Don't forget to put the squared here. And then the A in here, I have the A is X, right? So it's going to be X and then square again because the formula says it's squared. And then plus B, the B is 3. So this is going to be 3. And then don't forget that we have a square over here, right? Then again, this is just a very simple calculation, like algebraic calculation. So we can like subtract both sides by the. Okay, so maybe I'm gonna just square this one. 4 squared is 16. X squared stays x squared, and then 3 squared is 3 times 3, which is 9. And then I'm gonna subtract both sides by 9. So this is 16 minus 9 equals to x squared, and then 16 minus 9 is equals to 7. This is x squared, and then I'm gonna square root both sides. There we square root of 7 equals to x. So basically this is actually plus minus, guys, but remember that this is length, so length is going to be always going to be positive, so it's just equals to this. So which means that the shortest distance, so if I want to write down the conclusion, the shortest distance is square root of 7 centimeter. There you go. The next thing that we're going to investigate is the radius tangent. Okay, so previously I've already explained about what tangent is. So basically tangent is just a straight line that going across only it passes through one point on the circumference, right? So it doesn't, okay, so for example, if I have a point over here, for example, and then I have a point over here, for example. Now, if I drag a line from those 2 points, right? Wait, is it? Line here, right? So C to D. This is not a tangent because it crosses 2 points. Okay, so maybe I'm gonna go to line, not line segment, from here to here, right? So this is not line segment. This CD is a chord. So what is a tangent? A tangent is basically, it's just like if I just move that D exactly to C, right? So exactly there, right? Exactly on that sense, like it's stacking together. So this line is just passing through 1 point on the circumference, right? So basically this is what we call a tangent. This line here, this line is what we call a tangent, right? So for now I'm going to use the technology. I'm going to use this tangent here, so I'm just going to go to construct here, right? Go to tangent here, right? So I'm going to go to tangent, here we go, and then this is, there you go, right? So we have a tangent over here. So the investigation is, what is if I drag a line from A to C, which is going to be the radius of the circles, right? From A to C, this is the radius, right? So what is the connection between the radius and the this line over here? So what we're going to do is we're going to measure the angle. So let's say I have a line, I have any a point on the tangent anywhere I want. For example, here, it doesn't matter, right? Because we want to find the angle over here. Now we're going to find the angle EC2. Okay, can you see what happened is that the angle is 90 degree. Again, if I move it anywhere, right, it's not changing. It's always going to be 90 degree, right? So from this investigation, we know that if we have a tangent from a point on the circumference, and if you drag a line, a radius from the center point to that point on the circumference, right, to this point C, it will always make a 90-degree angle. So if I, for example, make another line from line segment from D to A, for example, this is going to be a right angle triangle. Then again, in a right angle triangle, we can use the Pythagoras formula. For example, if you want to find the distance from here to here, right, for example, that is going to be, we can use the Pythagoras formula to find the length of that line, right? Okay, so let's go to the example. Okay, example 3. The tangent from point M to the circle of radius 5 centimeter is 12 centimeter long. Find the distance from M to the center of the circle. Okay, now in here, it said that the tangent from point M, the tangent, it means that if it is a tangent, this TM, it means that if we have a radius, this is the radius of the circle. Again, guys, if you connect the center point to any point on the circumference, it's always going to be the radius. Okay, so that is going to be 5 centimeters. So from this point to here is going to be 5, because it said that the radius of the circle is 5 centimeters, right? So then again, guys, because this is a tangent, so this is going to be 90 degree. So if I add the line, if I continue this line here, this straight line, this is also going to be 90 degree. Okay, so it said that we have a point M, right, this M, and then the question is, find the distance from M, this point here, to the center of the circle. So we basically is going to find the length, this line over here, right? Then again, guys, because this is a right angle triangle, so you can use the Pythagoras formula. Okay, so the Pythagoras formula set is going to be C squared equals to A squared plus B squared. Okay, now the first thing again, guys, thing that you really need to do first is that to determine which one is the C. Remember that the C in the previous example is the hypotenuse or the longest side, and it is always going to be in front or opposite to the right angle triangle. So to the right angle. So this is the right angle, the 90-degree angle. So in front of that is this line over here. So this is going to be the C. Okay, so this is going to be A and B. Again, guys, the A and B doesn't really matter for this question, right? So you can have A over here, B over here. It's the same thing. Which means that we're going to find the C, right? So the C is the line of OM. So let's see B, just C. So C squared. And then the A, for example, I'm gonna choose the A is 5. So that will be 5 squared. Remember this, we have a square over here. And the B is 12, so just put 12 over here plus 12 and then squared. And this is calculate, right? 5 squared is 25, and 12 squared is 12 times 12, which is 144. If you add them together, we'll get 169. So because this is C squared, what we want to find is the C. So square root both sides, there'll be the square root of 169, and that'll be just equals to 13. So what does that mean? It means that the distance, right? The distance from M to the center point, sorry, is 13 centimeter. And again, guys, you can use the Pythagoras formula to answer this question. Okay, so after some investigation and some examples, I would like you to try these questions. Okay, so you can pause the video and then see the question and then try to do it yourself. Remember to answer question in systematical order. Okay, gambare.